Alright, in this podcast we're going to take a look at how to solve molarity problems when we have ions involved. Okay, so we're going to look at number 8 that's in the worksheet packet. Alright, so the question is, what is the molarity of each ion present in an aqueous solution of 24.5 grams of magnesium phosphate dissolved in enough water to make 655 milliliters of solution? So let's first take a look at what happens when I take magnesium phosphate. Let's write the formula first. Magnesium phosphate, that's a -3 ion. This is a +2 ion, so I need 3 of those and 2 of those. Okay, when I dissolve this in water, what it does is it breaks up into its 2 ions, just like any ionic compound will. So it's going to break up into that magnesium +2 and the phosphate ion, which is a -3. And if I have one of these, 1 mole of these, I'm going to get 3 moles of this, and I'm going to have 2 moles of this, right? So if they're in the same amount of solution, if I have 1 molar of this, 1 mole per liter of this, I'm going to have 3 moles per liter of this and 2 moles per liter of this. Okay, so I can triple the moles, or I can triple the molarity to get this. I can double the moles or double the molarity to get this. So let's first figure out the molarity of this solution. So if I have 24.5 grams of magnesium phosphate, what I know is that 1 mole weighs, let me see, 262.84 grams. This is going to give me 0.0932 moles of magnesium phosphate. And to get molarity, I can divide those number of moles by my liters, which is 0.655 liters, and I get an answer of 0.142 molar magnesium phosphate. Okay, so like we said, I'm going to triple the number of moles or the molarity of when I get to magnesium ions. So that's going to, if I multiply this times 3, I'm going to get, let me see, 0.426 molar magnesium, and I'm going to double the amount of phosphate ions, so I'm going to end up at 0.284, this is times 2, right, moles of phosphate ions. Alright, and that's how you do it.